Hi everyone. It's 1 o'clock in the Rocky Mountain West and the sun is shining, the clouds are bright, and it's time to start a talk about visualization for data analysis. I'm going to talk with you today about a way to look at data and explore content so that you can enjoy it a bit more and perhaps convey a lot more information through the same amount of content in a lot faster fashion. It means that the content is put in a better context for people to review. Let's go ahead and get started. Excuse me. There must be a way to move this slide. I'm sorry. It's been said for many, many years that a picture is worth 1,000 words, and we normally look at data in lists or citations or other text-based presentations, and at the same time, that data is being manipulated and presented as visual displays in many, many ways. So some of those ways include maps of sciences and things put over on places and spaces. And we're looking at increasing amounts of storage and computing power that make working with these digital assets really possible. So what's happening is that we are able to present trends and changes in research and direction and coverage and demographic data and so on in ways that are much more visually pleasing and actually convey a lot of information very quickly. And the reason that happens is because we have a lot more ability to show data overlap as well as white spaces, which is where the data does not exist on a topic. So in that case, we can look at where knowledge gaps are exposed. What I want to talk today is about how the data is prepared and the options for that visual display of content. What you've just seen is exactly 100 words, and if we multiply it by 10, it's 1,000 words. So why would we take a visual look? Since we're used to looking at data and lists and citations and other text-based presentations, what is different? What we're finding is that we can analyze the data, manipulate it, and present it as visual displays. Lots of arrays of information. We are increasingly familiar with looking at things like Google Maps and searching on a Google map for a hotel nearby to a place that we're going, for example. And it's because we have vast amounts of computer power, primarily in the cloud, but also locally on our own machines, that makes this possible. We no longer have a 48K main memory machine. We're up to machines with 500 megabytes and more on the standard desktop. That means that we're able to present data in new and visual ways to see trends, changes in research direction, how good our coverage is, what are demographic trends, and I'm going to show you some of those now. We also see where knowledge gaps are exposed or where data doesn't exist or where things are just simply not happening, and we see that quickly in a visual sense. For the visualization of data, we need to have some kinds of measurements available. We need to be able to keep metrics. So to plot things on a map, to graph it out, we need some kind of a metric measurement number base. What we can show using those is how close things are, where they have relationships. We can make connections between things where you didn't make connections before. So data is differently presented and therefore can be analyzed differently. We can show where things occur together, giving co-occurrence, and we can also show where things are actually not too closely related or some kind of conceptual difference between the data. When we have that kind of a display, we can make it even richer if we can link the data in advance if we can do some kind of semantic enrichment with a classification system or a taxonomy or an ontology, somehow to make that data richer, enhance the data, and once we've enhanced the data, we can enhance the visualization. And with additional data or mashups of different kinds of data, we can provide new looks at things that weren't possible before, which is how we're able to do some forecasting, trend analysis in looking at bigger pictures, as well as segmentation of the data and looking at little tiny pieces of it and seeing where the overlaps or the functional equivalence of data exist that we didn't know existed before. So we're looking at the distribution of data in a visual sense. This is not a new thing. Man's attention to how we display things and how we convey knowledge is actually pretty ancient. And it was used in many, many ways by people long ago to convert rituals into a record and to convey information, leave signs for people as they passed by. We know that some of the most beautiful maps are those that are of long ago. We have some beautiful presentations of places like this one in the lower left of Europe, or in the upper end of the world as they knew it at any given time. So these maps are from the 1600s, and they've become increasingly beautiful over time, differently displayed. This is a more modern map, and we see that we know where places are, and we know how to get there because they're signposted. So we have value-added metadata added by giving us the highway signs and place names so that we know where, across some geographic terrain, where things are located. We can look at ancient cities and see where places are exactly. In fact, these maps were used in early times for the tax rolls, so that we knew where the buildings were, how many of them there were, and what kind of assessment we should put on people to collect duties and taxes. Nowadays, we've moved to much more modern kinds of presentations, but still a visual display. So if we want to look at this emerging community and content map and fee versus free content, we can see where the growth is by plotting who is offering what kind of information. And then if we overlay that with the technologies, we can see where the rapid growth is and in what direction. So unstructured content is growing more rapidly through email and blogs and wikis, and information visualization as well, but the structured data with the semantic web, Google Scholar, and the many types of data mining activities that are out there are increasing the structure capabilities of data as well. So these graphs change over time. This one is from 2006, and I think we would find the whole thing has moved in those green and blue circles a bit to more to the extremes because of the amount of content that's available. And even publishers, with the advent of organizations like the Public Library of Science, have certainly moved where those blobs of data go. We also find that superimposing of data, or a mashup, is also an increasingly frequent example. This example that you see here is a traffic injury map showing incidents in the Nottingham, England area. But it's quite a few different pieces of data that have been overlaid all into the same map structure using a Google Maps base. So we have United Kingdom Data Archive data. We have U.S. National Highway Safety Administration data reporting different kinds of accidents. And the accident categories include those having a child involved, those having an automobile, those having a bicycle, and so on. And in addition, we can look at this map by date and time and place. So the place is currently displayed, but we could convert this map to show it for the number of child injuries using a bicycle at a particular time. Or we could notice that in one particular area on this map there are a whole lot more of one kind of accident than another. And then we can do some education and other kinds of traffic control things to learn to deal with these issues. So being able to plot this kind of information is very, very popular with the safety network that we have worldwide. So police departments and other organizations are using it on a regular basis. Another type of map is when you overlay things on different bases. So I just showed you one that was on top of a Google Maps base, and here in 2009, so a little bit older data, but you see that in July of 2009, Google Maps was used in about 45% of the time for mashups. Interestingly enough, Flickr was used 11 times, and Virtual Earth just 4 times. Now, if we move forward just 6 months, you can see that Google Maps is 30%, Twitter, and using Twitter Maps as a base was up to 20%, and other ones have come into the fore. So you didn't see GeoNames or Google Base or the Google App Engine earlier on, but you saw them not long after that, and Flickr has fallen to 5% in just a few months' time. This is a very, very active area. So the APIs, the application protocol interfaces that people use to overlay their data so that they can create mashups. This is a very rapidly changing activity. A lot of people are involved, and it's a very competitive area as well. This is another kind of way that we can look at it. So this is Radio 4, looking at a feeling about credit. So this is an instant sensitivity map on how people feel about credit. It was announced as a way to map the credit on the Radio 4 website, and it is a crowdsourced visualization mapping. So what we see is that people could log in or send information on how they felt about something to a very simple survey, and it can be reflected real time and using simple and broadly available tools like a website questionnaire. What we get is very early responses, and here you can see them on the map of the UK, not all that many, not all that fast, but within 4 hours it was populated this quickly. This much information was added dynamically to these maps through crowdsourcing using a simple web questionnaire so people could get a feel for who was listening and how they felt. I think it's interesting that way up to the north in Inverness area and in the Lake District, people were commenting much more voraciously than people down the more populated end of the country. So just an interesting idea of who you can reach through these kinds of crowdsourced visualizations and mappings. Another place that these kinds of mashups are used is in things like watching migration patterns. So this one, if you went to this YouTube site, you could see the bird path migration sites, and this one happens to be at night because most birds do fly at night. They eat during the day and then they fly at night. And this is a real-time mashup that's fed by an incredible amount of data sources. So people that are recording migration paths from their backyard feeders to the Cornell Ornithology Lab are participating in this. So this is another kind of crowdsourcing information base. It's one of the most successful, actually, where people are adding tons and tons of information, incredible amount of density in what they see, when they saw it, and how many they saw, and giving those data points so that you have the frequency as well as the type. You can plot the bird migration patterns. And in this particular case, they have added weather patterns as well, so you can see how the birds react and what they go around. And this is done by the minute, or you can view it by the hour throughout the day. So this one, which you can look at on YouTube, it moves across a 24-hour period and gives you an incredible amount of information about what's happening. And just for fun, they've also added an audio section so that you can hear, by using the listening stations at the weather stations nationwide, you can hear how loud or how soft the birds are as they chirp and navigate through the echoing of their calls at night. Another way to look at mashed-up data is live transportation data. So this one, which you could also find on YouTube, because a lot of these things are posted there, is you can see the ships moving back and forth and through the English Channel. So based on satellite data as well as filed paths, you see the ships and how they're moving as they give their radar location. So it's a live distribution of where the information is. You can see air traffic over Britain. You can see air traffic going back and forth from the U.S. to, well, worldwide actually, but the particularly interesting to me was the one flying from the U.S. to Europe, and you can see that most of the flights fly over at night and they fly back in the morning, and you can see the back and forth of individual planes coming back and forth. It's very fun to see what all this data looks like. Another application is where people report for noise ordinance situations, for example. So this is using instant messaging from Twitter with GPS sensing on the mobile devices. So people sending from their mobile phones with GPS enabled, sending Twitter accounts, give you an idea of where the noise patterns are in a particular area. So you can map that real time to see where the loud spots are, and you can overlay it on a Google map or other geo-based system, for example, and see what's noisy and where the problems are. Follow riots this way, for example. So the changes that we are seeing today, the changes in our lifetime, are just incredible. This is a schematic that says what is here now, but also what is possible. So you see the GPS data coming into the mobile device, and that is connecting into several databases to show where somebody is, what they're looking at, where they might be located, identifying the physical location with their camera by aiming the camera at a building, goes into a Flickr layer, and the Flickr photograph base identifies where they are. So if you're standing in front of the Empire State Building or the Washington Monument or some famous landmark in Chicago, you aim the camera at it, and the Flickr layer will tell you where exactly you are and what that item is. It will also give you directions to someplace else if you want them, and could also supply ads. So I could theoretically, if I had a pizza shop near the place that they were getting an image of, I could send an instant ad saying, well, while you're here, I'm having a $1 off coupon if you come in now and get a cup of coffee. So it's only the beginning, but this is what the back end of that kind of thing looks like. So the service architecture is very well established. So fine. We have a lot of nice visual maps. We've all seen the maps, but what does it take to make those maps? And how do we take the information we have on our desktops, or we have in databases, or we have in libraries, and move those to something that can be made visually pleasing and easier to interpret? So you start with data. So if you look at view source on a website, for example, you might get something that looks like this. This is a data source. And this kind of data needs to be massaged so that you can use it and convert it into a visual presentation. Because although this has color, unless you're a real aficionado, it doesn't really mean all that much to you. So the next step is to tag the data. And you can tag that data using subject terms from a thesaurus or taxonomy, for example, or from other knowledge organization systems. In this case, we have a date, we have a category, we have taxonomy terms that have been added, and very importantly, we have sorted these by frequency so we know how frequently we are seeing each of these terms. And in those term distribution frequencies, as you will see, we get a great deal of knowledge. So the first point is to get the data enriched to the point where you can map it. That particular set that I just showed you can be seen in many ways, and these are just simple tables that came out of Excel, so something that you could do this afternoon with a data set. One way to map it, another, yet another. This is all exactly the same data that we're looking at lots and lots of different ways. And because we have the frequency count of the number of times a term was used, we can get a good distribution of the data. And we can do that data over time. We can do it in a 2- or 3-way matrix. We can also do it in a target, so we know how the information is distributed over time. So, and we can look at any series of data. In this case, we've just done one series on this chart to see how it lays out and what the connections are of that data. So this is something you could do this afternoon. If you wanted to look further, I would direct you to something like the Prefuse Gallery. Prefuse is a visualization gallery of open source programs that people have contributed to, and they've contributed the source code as well. So if you like one of these, you can click on it, go to look at that site, and download the code or talk to the developer directly. And there's quite a few of them. You can see from the bar here that this is, in this screenshot, there's only a little bit. But if you go to perfuse.org and /go to the gallery, you'll find a lot of information on visualization toolkits. Lots of ways to lay out your data, and lots of ways to play with it that are fun. If you want to get a little more analytic, then I would go to something like PIAC. PIAC is a package for large amounts of data, and it's fairly straightforward. It is developed by some guys in Romania, and they happily share it. It's a very good program, and it is used very, very broadly by the people in the visualization business. So people say I PIAC'd it, or I used PIAC, and I have seen many, many networks using PIAC with their spider design. So if you're looking for something that's straightforward, easy, and quick to use, then use either something from Perfuse or use the PIAC software. Some of the leaders in visualization of what we know, and getting an idea of how to look at science and other domains in a very effective way, is this group at the University of Indiana, and a woman named Kathy Borner there heads up a visualization group that has an incredible amount of information, including arrays of information on her website. So this is also a very good site to go to. If you go to Kathy Borner's site at the University of Indiana, I think you'll find an incredible amount of resources plus a lot of information. And she does supply a gallery of information and a touring exhibit with about 70 different visualizations. I think edition 8 is now touring the nation and looking for hosts that want to hang a show of visualization of science. I'm really lucky because I'm on her advisory board, and it gives me a window into what's happening in the visualization front on visualization of science. One of the groups that's very active in visualization of data is the SciTech Strategies group, and they did this map of science, which has become pretty famous, and they also set up the colors that we use pretty broadly as a default. So biology is green because it's living, medical sciences are red, you can guess why. Engineering is is blue or purple, and as you look at the earth sciences are brown because they represent the Earth and so forth. So you can see this is based on a Scopus map of 16,000 journals and shows the distribution of science across domains and what the interconnections are between the sciences. So you see where a lot of interlinking happens here in biology and medicine. You see that the social sciences are linked to the health professions, but not so heavily to other things like biology or engineering. So very interesting way to look at the connections between science. Another map that was done for the National Science Foundation is a U.S. vulnerabilities in science. Where are we good and where are we not so good? Where are other people beating us? So what are our areas of expertise, and where should we maybe beef up our educational resources a little bit so that we can better serve the needs of the nation? If you wanted to look at the interrelationship between stem cell research, you could see where people had published papers on a particular stem extension and get an idea of where the overlaps are, where the action is, and also where the white space is. Where is there not much going on, not much happening, not any links between control of hemophysis and cell differentiation, for example. Should there be? Should there be papers that overlap in that area? Is that an area of research that's worth exploring? I have no idea, but perhaps. So the National Information Center for Educational Media worked with Sandia National Labs program called VX Insight and took their data and mapped it in 3 different ways. This is a database of non-print educational media used to serve the primary and secondary education needs in the United States particularly. So it's not textbooks, but it's the kits, it's the videos, it's the CDs, it's the audio recordings that people use. So when you look at it, I wanted to point out that there is a U.S. Valley of Science, which just follows on from the vulnerability of sciences. So let's look at the maps. This map, just one of the 3 views that we have here, shows you the connections. So these are the top terms of a classification system, the Nisem thesaurus at the very top, 2nd level terms, 3rd level terms, and so on. And you can see that some areas go deeper than other areas. But you also notice, if we look in the next view, which is a topographic view of the same area, what we have here is the information that shows the hills and valleys of information. So this valley right here is because science is not taught very much in the United States until the upper grades. And so if we look back at the grid map, you see that although we have science, it doesn't fall into biology and chemistry and physics and other areas until we get into the upper grades. And although they spread out below that, following the curriculum guidelines of the United States, we find that we have a valley of science compared to the other topics that are taught, like English and English, mathematics, even languages. So now I'd like to turn to a case study for the time that we have remaining. We looked at a collection from a large society publisher. In this case, it's the IEEE, which is the largest society publisher worldwide. And they were curious about what topical areas form the core and the periphery. Where do they have really dense coverage, and where are some opportunities for additional coverage? Where is the coverage fairly thin? And within those, what's most active? And where are things emerging? Where are they declining? And what's the overlap? Where are things interrelated? Where are they really islands all by themselves? And are there overlaps between the journals and journal segments? What are potential expansion points? Where could we look for additional conferences or additional journals or additional information points that are not, that look like they are emerging but are not currently covered? And we had done a thesaurus for the IEEE not too long ago. We had actually updated their thesaurus. So if we overlay that thesaurus on top of their actual information corpus, where were the terms too broad and where are they overloaded? Where should they be split apart? So this was the set of questions that we wanted to answer on the project, and we wanted to identify that core, but also concentrate on boundary and cross-border interactions. We needed to find the activity growth relatedness as well as centrality indicators. And if we just had the data and it wasn't already published within certain journals, they have 37 of them, would we reallocate the journals? I mean, would they be differently done? And of course, how might we improve the thesaurus, which is adding value to the system? So trying to build this map for the IEEE, giving all those adjacencies as well as the white space, which we would interpret as areas that are not covered and therefore opportunities for expansion, what do we need to look at? And if we were to look at the edges of science, where might they go in the future? What are the growth areas? Well, then we need some comparison data. What are other people looking at so that we can see the overlaps in fields that are not engineering fields? We also wanted to look at low occurrence rates in the IEEE documents and linkages between domains represented by the connections between the documents. So where do we find these terms and what are we going to do to add? Well, the first thing we did was build a rule base to auto-index the IEEE content. The client had gotten 90% accuracy for automatic indexing out of the box, so no customization needed on the journal data, and about 80% on the proceedings data. And proceedings data, as you can expect, is often PowerPoints, for example, so a little harder to have much meat to index against. We chose to find 3 overlapping data sets, and we used the data harmony tools to automatically index all 3 data sets. We took 1.2 million Explore records. That's the name of the IEEE database. So we took 1.2 million IEEE records. We took 10 years of U.S. patent data, and we took 10 years of Medline data so that we could get a feeling for where's the patents going, and one set of science might be bioengineering as an example of looking at the edges of science and seeing where the overlap is. Well, we had the IEEE thesaurus already, as I told you, so we used the rule base for the IEEE. We made a simple rule base using the medical subject headings from the National Library of Medicine, and then we took the Defense Technical Information Center thesaurus and made a simple rule base out of that so that we could get a comparative set. All 3 of these thesauri have a similar level of detail, and they've all been built pretty much to follow the NISO, the National Information Standards Organization Z39.19 standard for knowledge organization system thesaurus or controlled vocabulary creation. So this is what it looked like. We took the data in the 3 related corpus. So we had 14,000 DTIC terms and 475,000 patents. We had 2,000 terms for the IEEE and about 1.2 million documents. We had 24,000 mesh terms and about 525,000 PubMed documents. So those are the 3 data sets. And then we looked to identify what is related. So we used the IEEE thesaurus and indexed all 3 collections. And then, just to be comprehensive, we used the mesh and the DTIC to also index all 3 collections. And what we got were slices of data where the terms were applied so that we could look at some of the overlaps. So then we had co-indexed items from all 3 collections, something that got index terms from all 3 collections. And we made a term-to-term matrix to see where the articles and their indexing intersected. And you can see from the colors in the matrix where we find that overlap, and there's a pretty good core, not too much white spaces on the edges where we have some significant overlap. And then we took that data using visualization software, in this case primarily PIAC, but not absolutely, to do a bunch of different visualization examples. So what you see here, if you look at this line at the bottom, that's a term distribution. If you wrap that around a circle, you get this information, and the core, that's where the data centers in this particular case. We could instead do a scatter diagram of all of the records and see where they land. Or we could say we want to look at the collections based on the DTIC, the patent, Medline, and IEEE collections and see where the white space is in the middle of them. Or we could take all of the data and just take the top terms of the IEEE thesaurus and do a map of the data that way as well. So there are lots of ways to take exactly the same data and show it on a visualization map. In this case, we took all of the data and up-posted all the terms. So although the thesaurus has many levels, we only took all of the indexing, posted it to the next higher indexing term hierarchically until we got to the 52 top terms in this case. And the size of those circles indicates how much data there is in each of those collections. And the lines represent where items were co-indexed. And you can rotate this in the software, but of course in the screenshot I can't. But you can see that computers in information processing, for example, are connected to nearly everything, as are instrumentation and measurement. But vehicular and wireless technologies are, interestingly enough, coupled to communications technology, to oceanic engineering and marine technology, and into intelligent transportation systems. So it's interesting to see where the linkages are and where they are not. We then took the data to see what other kinds of linkages we could perhaps apply. So we looked at lots of different kinds of map options just to play with the visualization presentation of the data. One of the ways we looked at it was to take each of the journals, and I don't think you can read these, which is appropriate, and see where they cluster. So obviously on a ring, they cluster up here to the top, and then you have this space down here, which is not really covered. Should it be? Is this an area to explore? And what about this one over here? And you look at what these bubbles represent, and these are the same top term bubbles as we saw in the line diagram. And you can see where the overlaps are and what kind of places might overlap way too much. So in these, we see that there's lots of space between them. Obviously, those journal names are fairly well defined. Up here, we have a lot of journals that are kind of overlapping each other, and maybe their editorial policy is not entirely clear to the readership, or they have a loyal following and people have drifted onto new kinds of areas. So it's interesting to see where those overlaps are and interpret what you might be able to do with the data. It's obvious from this radial visualization that some of these systems like communications technology and computer and information processing are very heavily published areas, and some of the other areas not not so much publishing going on. Solid-state circuits and ultrasonics, for example, are not getting as much attention as they might have gotten when they started as a journal. So different ways to see how much information is being published, and also some of the overlap in those. In one particular journal, in this case, we laid out the journal of instrumentation by the top terms within that topical area. So the ones that are published the most, who's doing that publishing and on what topics, so that we can get an idea for the changes in science. So we produced 430 different diagrams from this project, and I can't, of course, share the results because they were used for strategic initiative positions, but the research team was 3 companies. It's Access Innovations with its Data Harmony toolset, SciTech Strategies, which does the visualization, a lot of the visualization strategies, and then, of course, the IEEE Indexing and Abstracting Group. We thank them very much for their data. Now, returning to other options, you can use a thesaurus, controlled vocabulary, to label the maps and to enrich the data so that the data is easily up-posted and added. And in this case, this is a very different kind of organization, and actually is selling things. There's information commerce underneath this, and you get a feel for how much of what they're actually making available. We could also use it to label maps and get an idea of what things are most popular and what things are pretty tight. So the questions answered by that were, can we use our own information to forecast where we're going? Well, if you're a publisher or a society, yes, you could. If you're a corporation, you could look at the internal memos or even the email and use that as a way to get a good idea of where you're spending your time, what you're talking about, and what directions you're going. If you're looking at industry publications, you can get an idea of where the industry is headed. And you can even parse it out by what technology sector. So it's a fast way to learn about where you're actually going. And then, of course, you could match that to see whether that matches your original mission and vision, and whether you want to realign the mission, realign the vision to match reality, or whether you need to do a course correction to ensure that you're going the way you really wanted to be going in the first place. So if you look at your data and potential markets, you might look at how you can learn from your data so that potential markets might become obvious to you in new ways. And in the case of societies and publishing, are they talking about what their own charter indicates that they cover, or are they talking about something else? We did another project in which we assessed the collection for a society, which won't be named, and found that one of their core journals had not published on the core topic of that journal for 10 years. So obviously the journal had a following, or it wouldn't have stayed in business, but it had migrated without migrating. It had migrated its content without migrating its mission and vision. So they were able to make a course correction, and when they did that, they significantly improved the circulation of the periodical. It's also fun to see, if you do this over time, what topics are emerging and which are cooling. So we got a 10-year slice, for example, in that IEEE data, and we could see where the industry was moving. And maybe it's possible to say that patents come out before proceedings papers, before peer-reviewed journal articles, and if you look at those, you can see a trend in a business in which way it's moving, particularly if you do date slices. And just like an old flip book, you can automate the images so that it moves quickly through through the years and you see what direction you're going. So that's a good way to use technology and your own data to explore questions about forecasting direction and learning about the industry. Somebody might decide to do a conference strategy, for example, by looking at where numbers are applied. So this is a demographic on where statistical numbers are used, and they're used heavily in the stock market, heavily in policy, and heavily in other kinds of metrics. And there's a little bit of overlap with the stock market, but a lot between demographic measures and policy measures. So maybe there's some new strategies for developing conferences that are just on metrics or just on policy or just on strategy, instead of trying to have one conference on all of those lumped together. A publishing strategy might be derived if you looked at the way that things were laid out. Perhaps if the data supports it, you could say these are the journals, or at least the sections of the journal that people are actively publishing on, actively talking about. Maybe that's where you should be thinking about following as well. So what we've looked at so far, and I guess I've run right through this, is finding the metrics. So we have to find the measurements, the numbers. In our case, we frequently use terms as indicators because we're dealing with textual material. So we're trying to overlay maps, looking at data that's been tagged with terminology, preferably from a controlled vocabulary, so that it's semantically enriched. And then using the frequency counts of those numbers, as I showed you in that early spreadsheet, to give us an indication of the values that we have for plotting the information on a map. It gives us a good way to show adjacency between terms. We might be able to leverage the relationships built into a controlled vocabulary or a knowledge organization system to show broader, narrower relationships. When we roll up terms, we also might see related terms that we hadn't realized were there, relationships that need to be explored. We looked at some ways to show trends and to show co-occurrence of documents or textual areas and areas of overlap. And we also looked at the white space. What are the conceptual differences and distances between information as we plotted out on these information-rich visualizations. When you are looking at the visualization of data, if you can enrich it by linking to other collections, like in the mashups, do semantic enrichment, like adding of controlled vocabularies or other kinds of classification systems, like we saw in the accident data overlay maps, then you're able to produce a much richer map. The more data you can, the more ways you can think to enrich your data, the more information you can add to the visualization and the more views you can get. We also have the maps supporting forecasting. We want to be able to support trend analysis, see where things are going. And normally with the trend analysis, we're looking at date timelines. So you look at the date of the information over time. And then also being able to delve down into specific collections to look at that segmentation. And when you go up again, you look at where the action really is. It's a good way to segment the market and determine what you're going after, what's of interest, what's important. And when you know the distribution of the field that you're dealing with, then you can serve that community in a much more effective fashion. Those effective maps are going to require contextual data, which means we've added data elements to the information so that it has lots of context. So it's not just text, but we've added a lot of information to make it contextual, to tell us things about that data. That's the information enrichment. We want to look at data at a very detailed level so that we can go from the very bottom up, from the tiniest element that we can find to code and organize. Then we can begin to coalesce and map and sort and plot the data so that we get a good idea of what's there. It's fairly easy to clump the data and lump it after you've got it tagged at a detailed level, but if it's not detailed tightly at the very basic level, then you get all kinds of biases into the information. It's better to introduce those biases in your analysis than it is to introduce the bias to the basic data collection itself. Classification methods, as we saw, is a way to add a lot of information to the data. We want to be able to enrich it as many ways as possible. For any map, you need at least 2 directions. You need to have at least 2 data points to plot it. So you can't make a map unless you have at least 2 values added onto the data. And then what we do is add a little art for fun, because it makes it a whole lot more interesting to deal with the data and a lot more fun to look at it, see it, and you can present a lot more information at the same time without going through reams and reams of paper to print a textual report. So what we're doing in the end is changing the way that we interact with reality. For Access Innovations, we work to ensure clean, well-formed content, and then we use our tools, the Data Harmony tool set, to automatically index the content, to create knowledge organization systems, to semantically enrich the content, and to organize it in as many ways as is practical on a particular data set. And with that, it only takes a little imagination to move forward. I want to thank you all for your time today. I'm going to look and see if there are any questions, and I don't seem to have any yet. So if, I don't know how to make this bigger. If you have a question, let me see, there's one here. Can you recommend any software for creating coded maps for use in deliverables, not websites? Can numeric and textual data be visualized together, and how would term analytics work for this kind of mashup? So let me take this question in pieces. Recommend any software for creating color-coded maps for use in deliverables and not in websites. And those would be, excuse me, software like the ones from the Perfuse collection are the ones that I would most recommend. What happens in that case is you have, you add the color to the data when you give the field a value. And so the colors go with the values. And then, well, like you looked in the SciTech Strategies data, you want to define colors that will have some meaning to the users. Can numeric and textual data be visualized together? And yes, it can, but we do need to add some kind of numbers to the text data in order to make it something that we can plot. So in the case where I showed you the frequency counts, it was the frequency counts that we were plotting, not the term itself. So the frequency gave you the idea of how important that information is. And then would term analytics work for this kind of mashup? And really, this is term analytics more than text analytics. And let me draw that distinction for you. The text analytics is something that people often use in conjunction with data mining activities, where they are using statistical approaches to the data to plot the co-occurrence and the relationships. What we've seen here today is different in that we're using the terms themselves automatically applied to the content to make it step up a level so that we have more information added to the to the records themselves, and we're able to analyze at a higher level than just looking at it as text analytics. And that's because those terms, if the term records are built as knowledge organization systems or thesauri or ontologies or taxonomies, that means that we've built relationships for them, and we have added synonyms and perhaps broader terms, narrower terms, and related terms as we went through the corpus and worked on trying to figure out how the information might be enriched. Let's see, will your slides be available for further review after the webinar? Yes, they will. You should get a follow-up email from Rachel Powell, I think a couple hours after this webinar, so that you can take a look at them. And of course, I would welcome any questions that you have directly. Again, what is the purpose of adding terms, and where do you get the terms? So the terms that we use are generally from a controlled vocabulary of some kind that we've added to the Data Harmony Thesaurus Master System, which is coupled to the automatic indexing system that we call MAI. Those terms, and there are a lot of controlled vocabularies available, but if you add those terms to the textual records, what you get is a much richer expression of the data in a much shorter period of time. Next question is, has this been recorded and where will it be hosted? Yes, it has been recorded, and to tell you the honest truth, I'm not sure where it will be hosted, but that message that you get from Rachel will tell you where it is hosted. Let's see, so let me ping here again and see if I have any other questions. Okay, looks like I have answered all the questions. I thank you all for attending. If you have any direct questions, feel free to email me at this address, mhlava@accessin.com, and I will, I think, after one more look at the questions box, close the session. Let's see. Yep, that's it. Thank you all very much. I will, now I'm getting a few thank yous, which is very gratifying. Thank you very much. And we will send you a list saying where the information is hosted. Thank you again. Have a great rest of the day, and I'll talk to you again soon.